There we go. What's up, everybody? Welcome back to another live stream from the Scalar Learning Channel. Good morning to everybody, and we are one day away from test day. That is tomorrow. So what I want to do today, this is the plan anyways, is to do a super extended live stream, all right? And what we're going to be doing is we're going to be going long. We're going to be going over everything I can muster in the next several hours in terms of SAT math content. We're going to do a formula review. I may do that at some point in the middle. I'm not going to start off right away with that unless I see overwhelmingly in the comments, hey, we want to see the formulas. That's what we want to go to. If that's the case, we can speed that up. But my original plan was to do this. Okay, I've been working through the Khan Academy series on my YouTube channel, and I think that's been really great and really helpful and beneficial for a lot of people. But today, we're jumping ahead from the foundations level. Now we're on to the medium level. So we got tons of time. We can do a lot more. We might do medium. We might even go through advanced. We're just going to kind of see how it goes with everybody. We'll hit up with the formulas. And I'm also going to take questions. So I see cameraman Dan that's asking for the formulas. We can certainly do that, like I said, if that seems to be the consensus. And in fact, I'll tell you what. Since I'm already seeing a request here, hold on one second. Let's start with that. Now, if you guys have noticed, okay, we've also got the SATcrashcourse.com at the top. This is, to me, this is the best resource out there for digital SAT prep. They've got the best practice materials in terms of practice tests. I've also collaborated with them, and I've made a series of video explanations. So basically, let's say you take their 10 tests and you want to know, hey, how do I solve question 21 on module 2 for practice test 4? There's a video for every single question from me on the resource. So it's a super awesome resource in terms of just the quality of the practice test. But then on top of it, you have the video explanations. It's gonna be a lifesaver. So if you guys need extra practice resources today, I would absolutely recommend signing up. Using the code SCALAR, you get 20% off. All right. Okay. So what we're going to do is, and Payvon said, thank you. You're very welcome. Very welcome. Okay. So when we're talking about, somebody's asking about linear versus exponential. We're going to get to that too through the topics. Since I saw that first request for the formula, let's front load it. Let's start with that and let's go through all these formulas. Now, I also have a video on the formulas called the Digital SAT Math Formula Bible. Okay, it's already out there. It's on the main YouTube channel page. So you can rewatch these formulas or kind of jump around if you need to. Oh, and very, very important, I released a video last night. Hold on, I'm going to show it to you guys. This one is super important, okay? So we're going to go to right here, Desmos hacks. This video is amazing. So basically there's so much you can do with Desmos on this test because the entire test allows a calculator. So you can bring in your own calculator as well, which I've talked about in the everything you need to know about the digital SAT video. So you can do that, but if you use Desmos, which I recommend because I think it's amazing, man, there are so many problems that you can just, boom, plug them into the calculator and knock them out, and you're good to go. So that's what that video shows you. Especially if you're doing some last-minute cramming and some last-minute prep, this video is key because it can bump your score massively. You just got to know how to use the calculator, and it's already fairly intuitive, so it doesn't take too much to kind of get in the flow of things. All right. So anyways, let's start with these formulas here. Now, the first thing that I want you guys to know when we're talking about formulas is you got to know what's on the formula sheet, right? You see this? So we have here, let's go to present mode. All right. So we have, let me go forward here. We have this guy, and the reason why it's so important is because you want to know what's on here, and you can click and access this at any time throughout the test, throughout the entire test. You just click, little drop-down comes. And look, it's got these great area and circumference formulas. We got Pythagorean theorem, special right triangles. So a lot of great things that if you don't remember them, you can pop this open and check it out. Also, look, this kind of tells you right here the relationship between degrees and radians, right? 360 degrees is equal to 2 pi radians. So knowing that conversion, they've been doing that a lot, at least on the practice questions I've seen, they've been doing that a lot in terms of that radian to degree conversion and vice versa. So it's right here. It's right on the reference sheet. You don't have to go very far. So definitely make sure you understand everything that's on here and how to find it. Okay, now let's go to slope of a line. So this is obviously a very important formula for linear equations. And you can get this by doing y2 minus y1 over x2 minus x1. I know I've gotten some people say, hey, you put the wrong formula in the past because I'll do y1 minus y2 over x1 minus x2. I changed it because people complained, but it's the same thing. It doesn't matter because, again, it's arbitrary, right? You're just choosing one xy coordinate to go first, one xy coordinate to go second. That's pretty much it. Okay. Hold on. Let's move this here. Okay, cool. Somebody says, how should I revise for tomorrow's exam? Rashid asked that. Yeah, I mean, the main thing I would do today, obviously joining the stream, you're a step in the right direction. We're going to do a lot of practice, ask questions. But then I would say now, hopefully the work is done and you don't have to go too hard tonight so you can still get good sleep and good rest and all that stuff. But, sorry guys. If you do feel the need to actually put in some deep work tonight, I would do a practice test personally. You can work, or like sections of it, just basically burn through practice problems, check it, make those mistakes now so you don't make them tomorrow. Don't think I'm making a mistake and now I'm totally ruined. I need to be perfect. You want to think about that process of making a mistake in the math problems as like, oh, I just taught myself something. I just learned something, etc. So that's a refinement process that you want to do now, not on test day or not after the test. Okay. So here's an example, right? We got these two coordinates. Again, arbitrarily, I'm assigning these as y2 and x2, and we're going to do the subtraction in that way. Now, if I did flip it to 1 minus 2 over 5 minus 7, we'd still get the same answer. We'd still get 1/2. But anyways, that's how you get the slope of a line. All right. Next, we're going to go to y equals mx plus b. Very, very, very important formula, as you all know, right? Slope-intercept form. And the important thing here is that we know that once it's in this format, that m represents the slope of the line, and this b represents the y-intercept. I'm going to show you what that looks like in a second. So we've got an example of y equals 2x plus 7. So on a graph, you can see that the y-intercept would be right here at 7, and that slope from every point to the next point is we're going up 2 over 1. There's the rise of 2 over 1. There's the run. That's how you do it. All right, number 3, point slope. So point slope is a great way to put together the equation of a line when you know a point and the slope, right? So again, m is our slope, and here's an example. We've got a slope of 3 over 2, and what is that 3 and that 4? And it's minusing, right? What is that minus 3 and minus 4? It actually represents the fact that there is a point on this line, 3, 4, and it's got that nice slope of 3 over 2, and you can see that here, right? We're going up 3 and over 2, or right 2, up 3 in this case, if you want to think about it that way. By the way, if you negate both of those, right, negative 3 divided by negative 2, that's the same as 3 over 2, but I'm just saying you can also think about it as going down left would be still a positive slope, just like going up to the right. Okay, my coffee is about to be here, and okay. Next, we got the midpoint formula. Midpoint formula is essentially the average of the x values and the y values of any 2 points. And you can see that that's basically all the formula is, right? You're doing x1 plus x2 divided by 2, y1 plus y2 divided by 2, and that finds the midpoint. So if we take an example here of these two points, 8, 4, 6, 7, to find the midpoint, we average the x's and the y's, and that would be 7, 5.5. Next, we have the distance formula. I'd say this comes up most often if you're like, hey, what's the length of the radius of a circle? And I know that I've got this center and this point on the, outside of the circle. Give me 1 second, guys. I'm just going to go grab my coffee. Literally 10 seconds. Hold on. Be right back. Thank you. All right, sorry guys. Here we go. This is a long stream and I'm gonna be here a while. So I got to get ready, get comfortable here with my coffee. Okay, anyways. So as I was saying with the distance formula, it's one of those things where it's not used a ton. I feel like there is usually, at least I haven't found, and this, this could change for tomorrow to some degree. You might see a question where it's just straight up, hey, what's the distance between these two coordinates? But usually it's in the context of like a circle, and you're finding the, burn myself. A circle, and you're finding the radius or something along those lines, right? But anyways, this is the distance formula. So as you can see, you're taking the difference of the x value, squaring it, difference of the y value, squaring it, adding them together, and then you're taking the square root. So we're going to give you an example here real quick for 2 points. So let's say we got 5, 3, and 1, 0, and we're trying to find the distance between these two. We're going to take the difference of them, right? 5 minus 1 squared, that's 4 squared, which is 16. 3 minus 0 is 3 squared, which is 9. Add those together, that's the square root of 25. Square root of 25 is, of course, 5. So that would be the exact distance between these 2 points. All right. Next, we're going to move on to length of an arc. Oh, I see some comments here. We're going to do hard questions, by the way, guys. Can you please do advanced algebra questions from Khan Academy? Actually, we can do advanced. Yeah. I was going to do medium first, but we can do advanced. Bro, you should get a good night's sleep. Yeah, I do look tired, huh? It's SAT week. This is how it goes. I'm tutoring late. I'm making videos. I'm trying to do this massive live stream for you guys. It is what it is. Yes, you're very welcome for going live, Chili Pepper. Very, very welcome. Okay. Now we go to length of an arc, n over 360 times 2 pi r. And this is important because if you're trying to get an arc length, if you notice, what is this really? It's circumference times a fraction of that central angle. And this is what it looks like, right? Where n is your central angle. So again, you're taking a slice of the crust. That's how I think about it. Area of a sector is similar. It's again that same fractional component, n over 360. But now it's times the typical area formula, which is pi r squared, right? So there's my little slice of pizza. And that's how you do it. Quadratic formula, very important on this test if you're trying to solve for quadratics or trying to solve for zeros of a quadratic. And if it's not factorable, obviously, and you'll see some of these questions will be like, if the solution for this is 2 plus the square root of k, what's k? And you're like, wait a minute, I have a radical in the solution for the x-intercept. Oh, it's probably not factorable as a result. Therefore, I'm going to need to use the quadratic formula. And that's can be an indication. But anyways, the way it works is if I have a quadratic in standard form, that's my a, b, and c. And you just straight plug and chug into that formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. Next is SOHCAHTOA. And on the SAT, the good news is you just need to know very basic trig. And that's sine, cosine, and tangent, and what they represent, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So here we have them listed out, right? And again, it's all relative to the angle you're choosing. Sine of A is different than sine of B, and so on and so forth. But in this triangle, sine of A is the blue over the green. Cosine of A is the brown over the green, adjacent over hypotenuse, and there's our tangent. Okay. Next, we have probability. That's the number of favorable outcomes over the total number of outcomes in general, right? So just if you want to remember, hey, what are the odds of getting a blue marble if we've got 3 blue marbles and 7 red marbles, right? Well, that would be 3. That's the number of green marbles out of the total, which is 10, 3 out of 10. Okay. Next, we have the circle equation, x minus h squared plus y minus k squared equals r squared. And it's important to remember when you have a circle equation in this format that the center is h comma k. So again, if it's x minus 2, it's 2 for the center, not negative 2, right? So h comma k. And then the radius is r. So whatever value is on the right-hand side, take the square root of that. That's your radius, all right? So here we go. X minus 2 squared plus y plus 5 squared equals 36. What is this circle? This is a circle with a center at 2, negative 5, and a radius of 6, square root of 36. Okay, here we go. Hey, look at this. So cameraman Dan just said he got a 100-point increase from 600s using Desmos single-handedly. So again, as I mentioned, I made that Desmos video, came out early this morning or late last night. It is so good, in my opinion, in terms of helping you guys boost your scores, because I throw in a lot of tricks there in terms of how to use Desmos, even for more sophisticated problems. You'll be amazed at what you can do. Now, obviously, there's always a way that you can solve it algebraically or by hand. You don't need Desmos, but it's a really, really effective tool. Okay. And all right, somebody asked, Striker, can we go over inscribed triangles and circles? Sure. If you actually have a problem that you want to point me towards in particular, that'd be even better. That'd be amazing, and I can do that. But if not, I can still talk about it. Okay, let's keep it going. So now we have exponential growth, a times 1 plus or minus r to the t. That's your initial value always for any exponential function. And that's your growth rate. So it's usually like a percentage turned into its decimal equivalent. So for example, oh, and by the way, the t is time, right? Number of years usually. Could say otherwise, but usually number of years. Exponential growth is where that r is going to be. You're going to be adding something. So we got an initial value of 200, growth rate of 13%, represented as 0.13, and time of 3 years, that would be this, right? Initial value, 1 plus 0.13 to the third power. And if we had exponential decay, that means it's decreasing in value, but it's very similar, right? Now we have a decay rate of 9%. So instead of 1 plus 0.09, it's 1 minus 0.09. That's the decimal equivalent of 9%. Here we go. Boom, done. By the way, Pyvind is asking, do I think tomorrow's exam is going to be hard? So what I'll say on that, and I see Striker, you did respond. Awesome. What I'll say on that is, I think it's going to be on the same general difficulty spectrum as most of the practice tests from the Blue Book. I was actually supposed to take the test tomorrow, but my registration was canceled by the College Board, and that's totally fine. That's their prerogative. I think, they obviously, I don't try to hide the fact that I'm a tutor taking the test. I know a lot of other tutors were planning to take it. It seems that they don't want tutors to take it yet. Totally fine. I get that. But anyways, my point is I was going to know firsthand. Now I won't. But here's the other thing to remember. Don't let that difficulty, whether it's going to be hard or easy, stress you out. And here's why. If you remember, they test, at least this happened with the paper test, so I'm assuming the same process is happening, called equating, where they're testing the difficulty in-house first, and then they're adjusting the curve as a result. So if you get a hard test, you might be like, oh, that's a bummer, but then you might be able to get 3 wrong on the math and still get an 800 or something like that. So it doesn't really matter. It's not something you should be concerned about. Okay, vertex of a parabola. If we have it in standard form, this is very, very useful and very, very helpful. The x value of the vertex is negative b over 2a. And if you wanted to find the corresponding y value of the vertex, just plug it in. So you get that value, plug it in, boom, done. Okay. Now we're going to talk about vertex form of a parabola. This is pretty cool. If that's my standard form, here's vertex form. And the cool thing about vertex form when it's in this format, a is just sort of a constant, and if it's positive, it's going up, negative, it's going down, but it also influences the stretch. But the h and the k, positive h and k as is, or like, the opposite of h, I should say, that is the vertex. Okay, so when it's in this format, you can see the vertex very clearly. Now we have the Pythagorean theorem. This is on the reference sheet, but I include it anyways because it's so important. A squared plus b squared equals c squared. A and b are sort of interchangeable. I can put them there like that. I call the other one a, the other one b. But c is the important one. That's the hypotenuse. C is always c. Very important. That's how you do it. Next, we have special right triangles. And special right triangles, we have 2 of them, 45, 45, 90. Where the legs are equal to each other, and the hypotenuse is x times the square root of 2, one of the legs times square root of 2. Then for a 30, 60, 90, we have like this, and in this one, I always start with that opposite side, or try and find the opposite side, the 30 first. That's our x. Then opposite the 60, if that's x rad 3, and the hypotenuse is 2x. So that's pretty cool. This is also on the reference sheet. Again, included it because it's very important. I want to explain it, but you can see this information there. It's cool because if you know, let's say you know the side opposite 60, and you're trying to find the other sides, you'll be like, oh, the side opposite 60 is 5 rad 3. And you can set that equal to x rad 3, right? You just set it equal to it, solve for x, and be like, oh, x is 5. That means the bottom side is 5, that side is 10. You see, so you can unravel it that way. Distance equals rate times time. You might be like, why are you including this? This is so obvious. But it really does help for certain rate problems. If you just remember distance equals rate times time, and just remember that rate has to be in the same units as what the distance is and what the time is, right? So if that's miles per hour, the distance needs to be miles and the time needs to be hours, not minutes or something. So there you go. Great formula. Underrated formula. Sine and cosine, this has to do with the relationship between sine and cosine. I see some questions. I'm going to answer them in 1 second. So the relationship that I want to point out is that sine of an angle is equal to cosine of the complement of that same angle. This used to get tested even more, I feel like, in the paper versions than some of the digital versions that I've seen. But I would say still have this in your back pocket. If you forget it, it's not the end of the world because there's workarounds. But it's just nice if you know that two angles are complementary. Sine of one equals cosine of the other. Okay, so I just gave a bunch of examples here, but you get the idea, right? Sine of 35 is equal to cosine of 55, and so on. Sum of solutions of a quadratic in standard form is negative b over a. Huge shortcut, okay? So you're like, hey, what are some of the solutions? Oh, okay, well, I'll find the solutions and I'll add them together. Yeah, you could do that. But look at this beautiful shortcut. You're just like, oh, it's 2x squared plus 7x minus 5. Sum of solutions are negative 7 over 2. That's it. That's how you do it. All right? Now, this is a new one, okay? This is not, I didn't used to include this on my formula sheet, but I do notice it on the new digital SAT practice test from the College Board, so I included it. Product of solutions, also a pretty simple solution. We have this in standard form. It's C over A, right? For sum, it's negative B over A. For product, it's C over A. So for example, we have this, right? What's the sum of the product of the two solutions? It is negative 5 over 2. That's how you do it. Okay. Next, we come to the discriminant. A lot of stuff on quadratics. Next, we come to the discriminant. And that is b squared minus 4ac when it's in standard form. And what does the discriminant tell us? It's usually about the nature of the roots, the nature of the solutions of a quadratic. So if they're like, hey, we need to know this value so that we get exactly one solution, that means we should end up with a discriminant of 0. We need two real solutions. Oh, that means a discriminant of greater than 0. I'm going to show you those right now. So here, this is an example where it's negative. The discriminant is less than 0. That means no real solution, okay? This is the situation when it's equal to 0. That's one real solution. And last but not least, greater than 0. That's two real solutions. Okay, moving on. Number 22, area of an equilateral triangle. All right, so let's say we have an equilateral triangle. By the way, there's a workaround for this. I'm not saying it's the most important formula, but just something to throw in your back pocket. Saves you a little bit of time. It is side length squared, right, because it's equilateral. All of them are the same, times rad 3 over 4. And here's a couple examples. If it's 1, it's 1 squared, rad 3 over 4. 2 squared, rad 3 over 4. Those would cancel out the 4s, and then 3 squared, or 9 rad 3 over 4. Okay, sorry, let me get some of these questions. So Sarah Yadav says, can you do circles? Yep, we're going to do all that stuff today. I'm going to be on here. This is a little surprise. I didn't want to tell you guys this. I'm planning to be on for like 4 or 5 hours today. So we're going to do a true marathon. So we're going to cover everything. Okay. And so I heard that the second section of March SAT is hella difficult. Well, again, maybe. I haven't heard anything like that, and that could be. But again, the Module 2 is supposed to always be harder, right? Especially if you level up and you get to the difficult section, if you do really well in Module 1. Any tip for word problems? Word problems are that's really general, right? There's word problems that are exponential word problems, quadratic word problems, right? So I wouldn't say word problems per se, I have a tip. It depends on the nature of the word problem. But if you want some general guidance, if all that information and knowledge and the text is getting you mixed up, generally what I would say to do is make sure to underline. This is such a big tip. This helped me so much because I always used to hate word problems too, actually. If you underline all the important numbers, both in text form or in number form. So you see like the number 2, underline it, whatever. Variables, underline it. And if you see the word 3 spelled out, underline that as well. That right there is a big help. The second thing is if you don't just like rely on the information in the format that's provided, like rewrite it and reformat it in a table or whatever is most useful for you so you can kind of parse all the information very quickly. Okay, Pythagorean triples. These are like 3, 4, 5s, 5, 12, 13s. Again, it's a time saver. Not essential, but a great time saver. The most common one is going to be the 3, 4, 5s, all right? And 5, 12, 13, that can show up too. 7, 24, 25, not as much. 8, 15, 17 can also definitely show up. And then you also have multiples of these, right? 3, 4, 5 can be doubled, tripled, quadrupled, and so on and so forth. And then we've got these ones. These are all different multiples of those and those. Again, just to give you an idea, if you see 16 and 30, ooh, to 34 is my last. I don't even have to use Pythagorean's theorem. These are just options, okay? All right. Now we've got perpendicular slope, right? If I know the slope of a line is a over b, the perpendicular slope is negative b over a, okay? And that's a nice little nifty trick, right? Here we have a line there. Perpendicular is negative 3 over 2. Now, I didn't say this, but parallel is the exact same, okay? So if one line has a slope of 2/3, the other line to be parallel needs to have a slope of 2/3 and a different y-intercept. That's it, okay? Next, we come to sum of angles, and this is for a polygon. Again, if you have triangle, 180, quadrilateral, 360, if you have some of these main ones memorized that are used most frequently on this test, that's going to be huge. So I would say, you know, this is not super critical, but this is a great workaround if you do forget some of those. And if you do get a bigger polygon, maybe a pentagon that you're not as familiar with. So the way it works is n is the number of sides. And what you do is you just plug it in, right? So for a triangle, you plug in 3, you get 180, right? Which that one you probably know. Quadrilateral, you plug in 4, you get 360. And a pentagon, you plug in 5, you get 540, okay? 26, we have rational functions. This is kind of new. I didn't put this on before, but now I'm noticing them coming up more and more and more, right? And that is just, you know, a polynomial over a polynomial, okay? So we're going to go over some basic tenets of these just to look out for when you're trying to match it up with the graph. That's usually how it's going to show up. So here's what one of these graphs generally looks like. And those numbers in green and red are important because that red number on top shows me the x-intercept where it's going to go to 0. Here it's 4, so I know it's going to have an x-intercept at 4, 0. That 3 on the the 3 on the bottom represents a vertical asymptote. And the main idea is the vertical asymptote occurs at the x value where you zero out the denominator because you can't divide by 0. So you notice the function actually doesn't go. It's like an invisible barrier. There's nothing there, okay? And we can also figure out the y-intercept very easily from this by just plugging in 0 for x, and we get negative 4 over 3, okay? So those are 3 really important points. Now we'll look at this example. We've got negative 2, 0, again for the x-intercept, a vertical asymptote at x equals 5, and a y-intercept of 0, negative 2/5. Okay. Triangle congruence theorems. These are very, very important. They've been tested more and more. I feel like even on the digital SAT as well as similarity. So these are the theorems you got to know, 5 of them. First one, side, side, side. That means all the sides are congruent. You know they're congruent. Side, angle, side. And that's important if you notice here. The angle that is congruent is in between those 2 congruent sides. That's important. We also have angle, side, angle. Angle, angle, side. And we have hypotenuse leg. Hypotenuse leg means for any 2 right triangles, if I know that one leg is congruent and one of the the hypotenuses are equal, I know by hypotenuse leg they're congruent. Triangle similarity, these theorems are important as well. Most important one is this one. Angle, angle similarity, if I see 2 angles congruent, angles are congruent, triangles are similar. Next one is side, angle, side, meaning not that the sides are congruent, but if I have 2 sets of sides that are proportionate and then the angle in between those sides are congruent, we have side, angle, side similarity. And then we have side, side, side similarity where all of the sides are proportionate, okay? And so you can go through, you know, side, side, side. We got that same consistent proportionate relationship throughout, okay? Next, we've got 29, unit circle, all right? So for the unit circle, we're going to see that, and by the way, you don't need to know the unit circle per se. It's not like this is essential either, but I do think it's nice, and I have noticed some questions come up where if you do have good knowledge of the unit circle, it makes it really easy, okay? So for example, we've got sine of theta equals y, cosine of theta equals x, and tangent of theta equals y over x. So what does that mean? That means if we know the unit circle, okay, sine of an angle is going to equal the y value in this coordinate, okay? Cosine of an angle is going to equal the x value, so on and so forth. So let me give you some examples. Sine of 45 equals rad 2 over 2, right? It's right there. It's that x value at 45. Cosine of 150, if we look at that coordinate there, it's the x value, negative rad 3 over 2. And then tangent of 240 is rad 3 because it's negative rad 3 over 2 divided by negative 1/2, all right? Next, we have foiling, all right? So foiling, this is if we have any two binomials, this is how you FOIL, all right? You multiply the first ones, you multiply the outer, the inner, and the last. So if we look at it, we get x squared, then we get x times negative 6, negative 6x, 3 times x, positive 3x, and then negative 6 times 3, negative 18. Now we can combine like terms, okay? And we got negative 6x plus 3x, and that's negative 3x. So we got x squared minus 3x minus 18, and that's how you do it. Okay, next we've got squaring a binomial. Let's say we have x plus 3 squared, okay? Remember, you might think, all right, cool, it's x squared plus 9, right? You square each individually. That is incorrect. That's a very common mistake. So instead, what you do when you do x plus 3 squared is you do x plus 3 times x plus 3. And we're going to, again, FOIL it. All right, so we got x squared plus 3x plus inner, which is 3x, plus outer, which is 9, combined like terms. We got x squared plus 6x plus 9. That's how you do it, okay? And we're going to now do exponent rules. When we multiply the same bases, we're adding the exponents. When we have that floating exponent, a power to a power, we multiply, okay? When we have quotient, something divided by something, we subtract the exponents. When I have a negative exponent like this, we're going to say 1 over x to the m power, okay? Anything to the 0th power is going to equal 1. Anything to the 1 power is just itself. And when we have a fractional exponent, you can put it into radical form, meaning we're taking the nth root and then to the m power. Let's see. We've got questions coming in. I have a doubt regarding quadratics, or we're going to do a lot of quadratics. How can we convert equations like this to vertex form? Oh, you're showing something that's not a quadratic. 6x to the 4th plus 2x squared plus 7. You're not going to get that. That's not a quadratic because it's to the 4th power. Okay, let me see. I mean, I can convert it to that format, but again, it's not a quadratic. But we're going to do some quadratic practice problems where we might need to convert to vertex form. Okay, so we'll come to that. Okay, so we're going to now just give some concrete examples here. 2 squared times 2 to the 3rd, we add those exponents. It becomes 2 to the 5th. Right? If we have more, and 2 to the 5th is 32. Then we have more examples. 2 squared to the 3rd, that's 2 to the, we take the product, 2 times 3, which is 2 to the 6th. That's 64 if you evaluate it. This one, we're going to be subtracting those exponents, which is 4 squared, or 16. 5 to the negative 3, again, that means 1 over 5 to the 3rd, or 1 over 125. 7 to the 0th, anything to the 0th is 1. Anything to the 1 is itself, in this case, which would be 9. And in this example, okay, I'm converting it. I'm taking the cube root of 8 squared. Now, this one's interesting. 8 squared is 64. Cube root of that is 4, okay? Or you could do it the other way. You could take the cube root of 8, which is 2, square that, and that's 4. All right, and I believe this is the last one, absolute value. This is how you solve an absolute value equation. I also talk about this in the Desmos video, so make sure you check that out as well. We split it, okay? We split it into two equations, x minus 4 equals 6, and x minus 4 equals negative 6. So the second one is the same, but we negate whatever's outside the absolute value. Now we're going to add 4 to both sides, and we get x equals 10. Over here, add 4 to both sides, and we get x equals -2. And those are our two solutions. You can plug them in and see that they both work, but that's how you do it. Oh, we got one more, inequalities. I think this is it. This is just one quick reminder. When you're solving an inequality, right, you solve it like a linear equation, but when you divide by a negative, something happens, okay? And you'll notice that everything was the same except I flipped the inequality. It went from less than to greater than. So now it's x is greater than -3. So that's just a reminder. When we divide or multiply both sides by a negative in an inequality, we got to flip that inequality. So it's just a reminder. Okay, let's go into some of these Khan Academy problems. I think people were saying, listen, I'm going to do medium. I'm going to be here for a very long time. So are you guys cool with me kind of burning through the medium, and then we'll eventually get to the advanced? I hope that's okay. By the way, if you guys do like this video as you're joining along and you appreciate what I'm doing today, please click that like button. If you do want to see more, make sure to click subscribe if you're going to continue your math journey. I would highly recommend that. And again, just a shout out, if you want to check out SAT Crash Course, the best resource for SAT math practice, you can do that, especially if you want to burn through a practice test today. All right, guys, let's have some fun. We're going to do tons and tons of problems. Here we go. Let me get my thing up here. All right. 3, 2, 1. All right. Which of the following is not a solution of this inequality? Well, let's solve it. Let's isolate. So we're going to -7 from both sides. That's -15 is less than -5x. Let's divide by -5. X is less than 3. Again, going back to that inequality rule, we had to flip it when you divide by a negative. So x is less than 3. So 2 is good, 1 is good, 0 is good. 3 is not good because 3 is not less than 3. Okay, next. What is the value of y in the equation shown? Let's isolate. Let's divide both sides by 2. Boom, boom. Now I have y plus 2 equals 3. Then we're going to -2 from both sides. Y equals 1. There's your winner. Done. Here we go. Next. 3ab minus 1 equals 2ab minus 3. What is the value of ab? Okay, we're just going to isolate. Those two variables, you might be like, what do we do with that? But that's just like its own term. So subtract it from both sides. We get ab minus 1 equals -3. Add 1 to both sides. ab equals -2. So C is the winner. Done. And this one, 3/4 x plus 2 is less than or equal to 11. What is the greatest possible value of this? All right, so we're going to -2 from both sides. 3/4 x is less than or equal to 9. And, oh, you know what? I just realized something. We can shortcut this. So look, now that I have this, I can actually -9 from both sides. So 3/4 x minus 9 is less than or equal to 0. And that's what they're asking about. So it can be anything. It can be 0 or less. So is that less than or equal to or less than? Wait. Oh, greatest possible value. It does. So it's possible. Yeah. So the greatest possible value is 0 because it can be less than or equal to 0. So B is the winner. But anyways, what I was going to do, my typical isolation is I was going to solve for x. So I was going to multiply both sides by 4/3. And that's x is less than or equal to 12. So then since the max value is 12, then I'd have to plug it back in. But I just realized we could circumvent that entire thing. But anyways, 3/4 of 12 is 9. 9 minus 9 is 0. So we get the same answer. Okay, that's it. Done. Moving on. And by the way, I'm seeing these problems for the first time in real time, so I'm really solving them with you guys. Hope you guys are enjoying it. Can't you do a course challenge? Cameraman Dan says. I don't know what you mean by that. Okay. An elite runner's stride rate is currently 168 strides per minute. The number of steps she takes per minute. She wants to improve her stride rate to 180 and believes that through training she can increase her stride rate by 2 strides per minute each day. Which equation best models the situation? All right. So she's got 168 strides per minute. She wants to improve it to 180, and she can improve by 2 strides per minute each day. So 2 per day. And she's currently at 168. and she can improve it by 2 per day, and she's trying to get it up to 180 and wants to know how many days it's going to take. That's basically it. I just talked it through and pieced it together as I was reading it, and that matches with B. That's a lot of times my strategy with these problems. Just kind of break it down, put it together as a relationship as you're reading it. A park shaped like a pentagon. Let's draw a pentagon. 5 sides. Has 4 equal side lengths and 1 unequal side length whose length is 35. Okay. The perimeter of the park is 195. So the rest of them are all X, right? What is the length in feet of one of the equal sides? So we can make an equation from this, right? Perimeter is all the sides added together. So 4x's plus 35, that equals 195. Now let's solve. Minus 35, minus 35, boom. 195 minus 35 is 160. And last but not least, we divide by 4, and x equals 40. Okay, next, here we go. At the beginning of the season, McDonald had to remove 5 orange trees from his farm. Each of the remaining trees, at the beginning of the season, okay, remove 5. Each of the remaining trees produced 210 oranges for a total harvest of 41,790. Okay, wait, total harvest. Each of the remaining trees, so 210 times T. Oh, wait. T is the initial number. Okay, I got it. So T is the initial number, but then we're minusing 5 from that, okay? And then of the remaining, because it says remaining trees, produce 210, and that equals this amount. And that's all they want. They just want a formula, and this matches with this formula. Okay, I hope that made sense. And last but not least, number 4. Raymond just got done jumping at super rounds. Total cost of a session was $43.25, and he had to pay a $7 entrance fee and $1.25 for every minute, which we'll call X on the trampoline. How many minutes did he spend? Okay, we just got to solve for X. You know what? Should we use some Des? Nah, it's fine. Okay, we'll use Desmos when we need it. Minus 7. That's 1.25X. Oh, wait, maybe we will. It's right there. 43 minus 7 is 36.25. And then we're going to divide by 1.25. Divide by 1.25. I think it goes to a different window. Let me try here. Yeah, it does. That's a bummer. I wish it would open in app. But anyways, 36.25 divided by 1.25 is 29. So there we go. 29 is the winner. Done. Okay. Moving on. All right, linear relationship word problems. Here we go. For practice and levels up masteries, a Khan Academy course challenge. Oh yeah. Yeah, I've seen that before. The reason why I don't want to do that or didn't want to do that, wasn't planning on it, was I wanted to really run through everything in a super thorough fashion. So that was my plan anyways. Okay. All right, a 300-room hotel collects $75 per occupied room and does not collect any money for vacant rooms. Which of the following functions best represents how many dollars the hotel generates if there are V vacant rooms? Oh, wait, so the ones that are not vacant would be 300 minus V, and then 75 per each of those. So 75 times 3, yeah, it's this one right here. So again, I'm not doing anything crazy. I'm just piecing it together as I'm reading it. All right, next, here we go. We've got the total payments P in dollars made by homeowner M months after starting payments, blah, blah, blah. What is the best interpretation of 67,000 shown? Okay. Total payments in dollars made by... This is probably the down payment, right? Because this is the monthly payment. That's M months. But this is probably the down payment. Or the first payment. So the first payment. Nope. Well, actually, it could be. It could be they paid it at the end of the first month, but probably not. The total of all payments made. No, it's not total. All right. Boom, done. Here we go. Next is when Lucia plays golf at the Rolling Hills Golf Course, she loses about 12 balls on average. When she plays golf at the Meandering, she loses about 8 balls on average, right? So let's underline those numbers. She lost approximately 100 balls after playing at Rolling Hills, which she loses 12 per, and Meandering Meadows, which she loses 8 per, so 8 times each of those. And that's it. There's our equation. 12R plus 8M equals 100. Boom. Okay, last one. Here we go. We've got the equation models the cost if Almond picks B rounds of blueberries and R rounds of raspberries at a farm where blueberries cost $5.50 and that costs $4. According to the equation, how much does Almond spend in total on both types? This means this value here. The total is what we have on the oops. It's glitching. It's what we have on that side. Right? That's the amount spent there. That's the amount spent there. That's the total. So 28 is the total. Oops. Oh boy. It's glitching. It's glitching. 28 is the winner. Done. Okay. All right, let's keep it going. Let's keep it going. Oh, I have a special treat for you guys, by the way. A very special treat. We are going to be able to do a practice test from the SAT crash course as well today. All right, so if you guys stick around, that's going to be amazing. We're going to do a full digital SAT from the SAT crash course, which is again listed at the top. So make sure to stay tuned for that. We're going to burn through, let me try and burn through all these medium level problems. Let's see how long it takes. But then at some point, if you guys do want to see a practice test more urgently than some of these problems, let me know and we can do that. I can throw it in earlier. Okay. Graphs of linear equations and functions. Here we go. The equation is graphed in the xy plane. Which of the following is a true statement about the graph? All right. So they're talking about the x-intercept and the y-intercept. So the thing is, when we're in standard form, it's actually easy to get the x and y-intercept because the x-intercept occurs when y equals 0. The y-intercept occurs when x equals 0. So I can figure this out, right? If I plug in 0 for y, that goes away. Divide by -3, x equals -5/3. If I plug in 0 for x, divide by 6, the y-intercept is 5/6. Now I have it. So x-intercept, y-intercept. So x-intercept is -5/3, y-intercept is 5/6. B is the winner. That's how you do it. Okay, next. Here we go. A line is graph, which of the following is an equation of the line. All right, so let's piece together. I saw it in slope-intercept form. I got a y-intercept of 1, and I got a slope of, let's see if I can figure it out. It goes, there's another nice point here, I think. So from the y-intercept to there, we're going up 3/7. So I should see y equals 3/7x plus 1. There it is. A is the winner. Done. What is the slope of the line represented by equation? Blah, blah, blah. All right, slope, we have to get into slope-intercept form. So we've got -3y. I'm going to minus x from both sides, -x plus 10. Then I'm going to divide by -3. Y equals 1/3, right, because that's an invisible 1, and the negatives cancel out. X minus 10/3. But they wanted the slope, and that's just the value. Multiplying x, that's 1/3, 1/3 for the win. Done. Okay, which of the following is true for this in the xy plane? They want to know about they're asking about the x-intercept and the, okay, let's see. What I'm going to do here, I'm going to put this into slope-intercept form. It's just going to be easier. So I'm going to add x/6. So I got y/9 equals x/6 plus 1. I'm going to multiply everything by 9. Y equals 9/6 is just 3/2. And then plus 9. Okay. So now I can see that the y-intercept is 9. The x-intercept, I don't know because, yeah, the x-intercept is -6. Because look, if I plug in 0 for y, 0 equals 3/2x plus 9, minus 9 from both sides. -9 equals 3/2x. Multiply both sides by 2/3, which is the reciprocal. 2/3 of -9 is -6. So what did I say? X-intercept. Yeah, this one. X-intercept is it's right. Let's just look at these other ones. X-intercept is 9. No, it's the y-intercept. Slope is 2/3. No, slope is 3/2. And it's positive, not negative. So There we go. Okay, done. All right, people are saying practice test. They want to see the practice test. They feel more basic. All right. Ask and you shall receive. All right. We're going to go to the SAT crash course. Come on. Make sure I'm logged in here. Uh-oh. All right, hold on 1 second, guys. I got to make sure something's glitching. Let me just make sure I'm logged. I can log in here. And then I'll bring it back. Uh-oh. Did we get it? All right, I'm still working on it. I don't know what's going on with the login. Come on, come on. All right, 1 second. Let me do it like this. Boom. Ah, here we go. Switch accounts. Okay, use another account. Okay, hold on 1 second. All right, guys, give me 1 second. Make sure to put those questions in the section as well. 1 second. Oh boy, hold on. Come on, log in, baby, log in. Let's go. Okay, got that, and then now, come on, log in. Uh-oh. All right, something's glitching on the sign-in. I'm not sure exactly why this is happening. Hold on. Oh, there we go. There we go. I think I got it. Okay. All right. Let's see if we can get in there. Come on, come on. Yes. Got him. Yeah. All right. Practice test for all of you. Here we go. The only thing is I need to get my little annotation tool up here. Hold on, let me figure out how to do that. Give me 1 second. So I know I have it on this one. Sorry, give me 2 seconds, guys. Just wasn't planning to do this, so. How can I get? Okay, give me. I think I know what to do. We need web paint. Okay. Chrome extension. Boom. All right. Hope you guys are still with me. I'm almost here. Okay. Just trying to make this look as nice as possible for you guys. All right. Okay, I think we got it now. All right, let's bring it over here. We're gonna make sure that was working. Might have to reload. Boom, boom. Let's refresh. All right, it's not popping up. I'm not sure how we're gonna do this. Okay, so instead, maybe we'll go like this. I got a little workaround. Here we're gonna go Miro, and we'll have a little whiteboard like this up here. Okay. All right, so when I need it, I'll kind of just pop this open, and you can see me annotate here. Okay? Uh-oh. Oh, shoot. Uh-oh, I think I might be gone here. All right, sorry, guys. I don't know if I just, did I just log off for a second? I don't know what just happened. Hopefully the stream didn't cancel out there. Because I just realized I accidentally logged out of my account. All right, let me double check here. All right. Are you guys all still with me? Do with Desmos for March 9th. Let's move practice test. Okay. Hopefully you guys are still all with me. Just let me know if you can still see me, hopefully. Okay. And we're going to do this practice test. Let's do it. Here we go. Come on. Wait, why is this not working? Oh, the extension is drawing. I see. I just can't see it. All right, how do I turn this off? Okay, let's turn it off for now. That's funny. It is actually working. But now I want it off. Okay, here we go. That's funny. All right. Oh, there is an annotate, but no, but I don't think it's gonna show up for the math. Okay. Let's skip through this. All right, hold on. Let's skip through this. Next, skip through this. Okay, ladies and gentlemen, we are about to start. We are doing this practice test from the SAT crash course. And I'm doing it for the first time in real time, so without further ado, let's see how we do it. And as I do it, I'm going to explain and teach throughout the process. So here we go. Boom, boom, and begin. What is the median of the given data? All right, so median is the middle value, and we have to put them in order to calculate the median. But the nice thing is they are in order, right? Increasing order. And we got 9 values. So the middle value is that 5th value. 6 is the winner. Boom, done. All right, number 2. Which expression is equivalent to this? So there's doing a little bit of factoring. And here, let's pull this in front so I can write this out. I'll factor it up top for you guys. Did they factor out a GCF? No, they didn't. Okay, so we're just going to factor it as is. Usually I would factor out a GCF. Actually, let's just do it the way I would usually do it. I'm going to factor out a GCF, x squared plus x minus 12. Then I'm going to factor that. What two numbers multiply negative 12 add to 1 right there. That's x plus 4, x minus 3. Okay, so I don't think they have this answer, but let's see if they did anything else. 2x. Yeah, it looks like it's going to be 2x plus 8, 2x minus 8. It's probably D, because what they did is they took the 4 and they took 2 and multiplied it in this one, 2 and multiplied it in there. But I'm going to show you why that's correct. So here, let me show you here. So if I multiply this out, I get 4x squared, 16x, negative 12x, which adds to 4x, and then negative 48. So D is the winner. These other ones, that gives you 4x squared, negative 3, and 16. That would give you 13x. This one would give me negative 12, and 4x would be 8x. And this one would give me negative 16x, 12x. That would give me the 4x in the middle, negative 48. Wait. 16, negative 2. Oh, yeah. This would give me negative 4x, not positive 4x. So anyways, D is the winner. Done. Jim drives his car at a speed of 50 miles per hour and rides his bike at a speed of 12 miles per hour. He drives for D hours and bikes for B hours. Total driving distance is 90 more. Okay, let's write all this out. So there's a lot of information here. Oops. So it says he drives at 50 miles per hour and rides his bike at 12 miles per hour. He drives for D hours, so 50 times D, that would be the number of miles he drives, and bikes for B hours, so 12 times B. And the total driving distance is, and then, so this equals whatever. And then the total driving distance, which is 50D, is 90 more than total biking distance, okay? Oh, that's our equation, actually. 50D equals 12B plus... It's A. Because look, all they did was they minus 12b. So 50d minus 12b is 90. Yeah. A is the winner. Boom. Done. 4. In triangle XYZ, again, we're going to need to draw. Sorry for this clunky setup. Okay. XYZ, we got X is 40, and that's here. And the measure of Y is 3 times the angle Z. So we'll say Y and Z. So this is, let's call it 3A and A. Okay, what is the measure of angle Z? All right, so we can make an equation here, right? We know that letter Z is represented by A. We add these all up, it adds up to 180. So 4A plus 40 equals 180. Minus 40 from both sides. 140 equals 4A. Divide both sides by 4. That's 35. So anyways, 35 is the winner. Let's just make sure Y is 3 times 40. So 3 times 35 is 105. And that makes 140 plus 40 is 180. Boom, done. All right, number 5. A tutoring company charges a registration fee plus an hourly rate for each hour of tutoring. Total cost in dollars for X hours of tutoring can be represented by this. What is the best interpretation of coefficient X? Okay, so the coefficient of X is always going to be my slope, my rate of change. It's going to be probably the charge per something, per hour in this case. So that means it's the hourly rate. Companies charge is $25 per hour of tutoring after that original hour. Yeah, that's it. 6. A class of 25 students is divided into groups of 5. The table shows the number of students in each group who have a sibling in the same class. If a student is chosen at random, what is the probability that the student has a sibling in the same class? Hold on. Students with a sibling. Okay, group 1, we have 1, 2, 0, 1, 3. All right, so it's 25. And so they're each 5 groups. If a student is chosen at random, okay, probability that they have a sibling in the same class. So there are 1, 2, that's 3, 4, 7. So there's 7 students total that have siblings out of a total of 25. So your probability is 7 out of 25. Remember I did the probability, I said it's the number of the things that you're trying to get over the total, and that's 7 here with siblings out of a total of 25. So that's it. As a decimal, if you wanted, you could put it in decimals. I think it's 0.28. Okay, from a population of 80,000 people, random sample of 1,000 voters was surveyed to estimate the percentage of voters. Okay, survey found that 52% support the candidate with a margin of error of 4%. As soon as I see that margin of error, I'm going to say minus 4, which is 48%, plus 4, which is 56%. We're going to go, this is the zone, okay? Which of the following is a possible value for the total number of the 80,000 surveyed? Out of the 80,000 surveyed. Out of the 1,000 surveyed, but 80,000 total, okay? So what we need to do is we need to calculate these values. 48% and 56% of that 80,000. So let's do that now. And 52%. So here are my two values. It should be between 38,400 and 41,600. So plausible needs to be any value in between those two, which would be, well, I guess this is on the fringes, so this would be plausible. 36,000 is too low, 50,000 is too high, so we'll go with 41,600. That's how you do it. Okay, what is the product of solutions to the given equation? Okay, let's see. So we got a quadratic. Remember I talked about this formula in the formula part. So we're going to cross multiply. We got x squared plus 29, right? Those two multiply, and those two multiply equals 3 times 3x is 9x. 3 times 5 is 15. Then we're going to subtract both sides. We got x squared minus 9x. Subtracting 15 would be plus 14 is equal to 0. Again, the product of the solutions is going to be c over a, which is 14 over 1, which is 14. So that's the shortcut. So we can put 14. Now I'm going to show you how to do this in Desmo since we're going to have the time. So again, we have 3. If you haven't watched the Desmos hack video, oh my God, you have to watch it. Worked really hard on it, and I think it came out really well. But here's a little snippet. I put one side of the equation as one equation. On the other side, I put y equals 1/3. And I look to see where they intersect. Okay? And they intersect right here when x equals 2. Oof. And right here when x equals 7. It's a little hard to see. Wait, here we can change the settings. Hold on. Let's make it y between, here we'll say -1, and let's shrink that down to like 2, I guess, or something. So it's a little bit easier. Okay. Now you can see 1 intersection, 2 intersections. Product of 2 and 7 is 14. Boom, done. All right. A radioactive substance. It decays at a constant rate of 5% per year. If the initial mass of the substance is 100 grams, what type of function best... So it decays at a constant rate of 5% per year. If the initial mass is 100, what type of function best models this relationship? So if it's 5% per year of the previous value, that we're talking about exponential decay, okay? So it's decreasing exponential decay versus, hey, it's dropping by 2 grams every year. 2, okay? That's linear. If the function m is graphed in the xy plane where what is the y-intercept? All right, so this is just plugging in 0 for x. That's 2 times 0, 0. 6 to the 0th is 1 times 1/2 is 1/2. So 0, 1/2 is the winner. Notice all the answers have 0 because the x-intercept is going to have 0. Again, I could graph this and literally see where it is, but, you know, that's pretty quick to plug it in. Circle has a circumference of 12 pi, and that means... Since 2 pi r is the formula for circumference, divide by pi, divide by pi, divide by 2, the radius is 6, okay? And, oh, it doesn't even matter. It says the length of PQ is 1/3 of the circumference, okay? So that means it would be like from here to here. And what is the measure of the central angle? Well, if the arc is 1/3 of the circumference, the central angle is 1/3 of the total degrees in the circle. So 1/3 of 360 is 120. So C is the winner. Done. A trapezoid has bases of W units and W plus 8 units and a height of W minus 2. Okay, so we got a little equation here. Now, trapezoid, not on my formula sheet, not super common, but you can piece it together if you need to, okay, in a couple different ways. You can think about a trapezoid as, you know, if you chop off the triangles, you can turn it into a rectangle, and then you can kind of combine the triangles to a second rectangle. So that's one option. But I'm going to show you, look, we do have W plus 8. That's the bigger one. That's one base. W minus 2. The bases are parallel. And then it says a height. W and W plus 8. Excuse me. And then a height of W minus 2. And it's giving us the area. Now, how do we do the area? Again, when we're talking about that conversion to a rectangle, like chopping the triangles off, another way to think about it is when we do the area formula, you're kind of averaging out the bases and saying, all right, if this were a rectangle, it'd just be length times width. Well, how do you take the average of those two top bases? You literally add them together and divide by 2. That's the formula. So W plus 8 divided by 2, average of the bases times the height equals 55. Okay. See if we can get some more work in here. So we got 2W plus 8 divided by 2 is W plus 4. So W plus 4 times W minus 2. You know what? And I'm just going to go to Desmos now. I could FOIL this out and do the whole thing, but watch this. So W plus 4, W minus 2. We're going to go with X here. X plus 4, X minus 2. And we're trying to figure out when this equals 55. So we're going to zoom out. We got to see 55 up here. And that's when W is 7 or X is 7. So either 7 or -9. Negative doesn't make sense. So we know that 7 is the winner. I think it was asking for W. Yep, that's it. Boom, done. And then we can check it, right? That would be 15 and 7. Average of those is 11. And then 7 minus 2 is 5. 5 times 11 is 55. Boom, done. Okay. 13. Number of bacteria in a petri dish doubles every hour. The table below shows a relationship between T and time and number of bacteria, which the following equation best represents. Okay. So it doubles every hour. So it needs to be 2 inside to the... It's C, I mean. Okay, I'm going to show you why. So when something's doubling, we need a 2 in there. And when it shows an initial value of 50, meaning we plug in 0, you get 50. 50 should be the number in front. So the only place where I see that is B and C, but this is the correct one. And then if you're not sure, you can check, right? Plug in 1, we should get 100. If I plug in 1 here, I get 100. If I plug in 1 here, I get 150. And then 2, we should get 200. You plug in 2. 2 squared is 4 times 50 is 200. Boom, done. Okay. 14. How many points do these intersect? I'm going to go straight to the calculator. We're not even going to do it algebraically. Check it out. So we've got 3x minus 5y equals negative 15. And then we've got negative 6x plus 10y equals 30. Okay, and let's check out these equations. Oh, wait. I think they're right on top of each other. Yeah, look, they're right on top of each other. The same equation, so it's infinitely many. Oh, yeah, and that's also obvious. Look, if I multiply this one by negative 2, I get negative 6x plus 10y equals 30. So, boom, same equation, infinite intersection points. A book fair students can purchase fiction and nonfiction. One student purchased X fiction, Y nonfiction, earning a total of 630. The equation represents how many points is the sum of 1 and 1, fiction and nonfiction. So this is points per is 9, points per is 45. You add those together, it's 54. 16, the mass of a radioactive substance decreases by 20% every 5 days. Okay. If the initial mass is 500, which equation represents the mass? All right. I'm going to show you how to piece it together kind of organically, if you will, just from what it's saying and from my exponential formula thing, right? So we have an initial value of 500, and it's decreasing by 20%. That's 1 minus 0.2. Now here's the tricky part. It says every 5 days. So normally it'd just be like t, right? But if t is number of days, I don't want to plug in 5 and then it's, doing that 5 times. So it's t divided by 5. And this is the formula. Now, this is one way to do it, but that requires you to obviously know a lot of this stuff and be able to execute. 1 minus 0.2 is 0.8, by the way, so it's B. But the other way you can think about it is you can say, well, wait a minute. I can do some of this math mentally. Like, for example, if I were to plug in 5, I should have a 20% decrease, which would be 400. If I plug in 5 here, nope, I get 100. If I plug in 5 here, I get something bigger. That doesn't make sense. If I plug in 5 here, well, I don't even know what I would get. That's like that D makes absolutely no sense. I'm not even going to test it, but you can check the values that way, right? 0, you should get 500, which this one you definitely don't. Here you get 5, so that's out. And then 5, you should get 400. Rectangular prism, I'm going to draw it out. Has a length of 6 inches and a width of 4 and a height of 3. What is the surface area? All right, surface area is the area of each face added together. So this one is 3 by 4, which is 12. And then there's 2 of those because there's another one there. The front face is 3 by 6, which is 18. Again, there's 2 of those. And then we got the bottom and the top, which is 4 times 6, which is 24. Okay, so now we got them. Let's add them up. 24 plus 24 is 48. 12 plus 12 is 24. 18 plus 18 is 36. 36 plus 24 is 60. Plus 48 is 108. And that's how you do it. C is the winner. Number 18, solution given system of equations x, y. What's the value of y? All right. I am going to, let's solve it algebraically. I already did one where I graphed it on Desmos. I'm going to multiply the bottom one. Wait, we're trying to solve for y, so let's eliminate the x's. I'm going to multiply the bottom one by negative 2. So I get negative 4x minus 2y equals 8. We're going to add these together. Goodbye. 6 minus 2 is 4y. 24 plus 8 is 32 divided by 4. Y equals 8. And 8 is the winner, D. Now, I'm going to check it, right? If y is 8, then x would have to be, 8. X would have to be negative 6, right? Negative 12 plus 8 is negative 4. So 8 and negative 6 needs to work here as well. 8 times 6 is 48. Negative 6 times 4 is negative 24. Add them together, get 24. Boom, done. Okay. Triangle XYZ, angle Y is a right angle. Sine X is 7 over 25. What is the value of cosine of X? Okay. So X, Y, Z. We've got Y is a right angle. We've got X, and we've got Z. Okay, so check this out. Sine of X, that's opposite over hypotenuse. Now, does it mean definitively that the sides are 7 and 25? No, but for the intents of this question, I can call it 7 and 25 because it satisfies the ratio. What is the value of cosine of X, meaning adjacent over hypotenuse? Well, we can use Pythagorean's theorem now to figure out this side. Although this is a Pythagorean triple. It's a 7, 24, 25. But if you didn't know that, 25 squared is 625. 7 squared is 49. You minus the 2. Let's just do it anyways. 6, 5, 11, 7. And then the square root of this is 24. But anyways, Cosine of x adjacent over hypotenuse, 24 over 25. Okay, next. What is the minimum value of p of x? Again, this is a quadratic. The minimum value is the function value, but I can find the x value of the minimum, or the vertex, at negative b over 2a. So negative b is negative 30, which is 30 over 2a. 2 times 5 is 10. That's 3. So the x value is 3. What's the corresponding y value? Plug and chug. 3 squared is 9 times 5 is 45. Minus 90 plus 25. So that's negative 45 plus 25 is negative 20. So the minimum value is negative 20. Now we can double check that at Desmos just for fun. So that is 5x squared minus 30x plus 25. And there's the bottom of the vertex, negative 20. That's how you do it. 21, line P. Hey, you're very welcome. You're very welcome. P said thank you. You're welcome. And what's up, Mabagwu Collins? What's up? All right, line P in the xy plane passes through this and this. If line P is parallel to the line represented by the equation this, what is the value of r? Okay, let's see. So if it's parallel, obviously the slope is 1/3, right? Because it's parallel to this, so same slope. And then we've got 2 points. We got negative 3, 0, and we've got 6, comma r. And we need the slope of this line to equal 1/3. So let's do the point slope. 0 minus r, subtract down, equals negative 3 minus 6. That's negative r over negative 9, which is r over 9, and that's supposed to equal 1/3. Cross, cross. I've got 9 equals 3r. Divide by 3, r equals 3. For the win, done. Okay, last one. In the xy plane, a line with equation 5y equals f for some constant does not intersect a parabola at any point. Wait, 5y equals f for some constant does not intersect a parabola at any point. Okay. By the way, I'm going to rewrite that as y equals f over 5. If the parabola has that equation, what is the least possible integer value of f? Oh, that's actually going down, by the way. So that's negative 4x squared plus 5x plus 3. Okay. So it's got to be above it. So it's like, hey, the bottom line is this, okay? If I find the vertex, that's the highest point. So this would have to be above that highest point. So I could do it algebraically very easily. And you know what? I'm going to do it. But I'll also show you on Desmos. It's pretty straightforward as well. This is our last question, so I can take a little bit of time. We got plenty of time. So the vertex is, again, negative b over 2a, which is negative 5 over negative 8. So my vertex is occurring at 5/8, comma something. Ooh, this is going to be annoying to plug in. I can do it. Okay, so that's 25 over 64 times negative 4. 25, that's negative 25 over 16 plus 5 times 5 over 8, that's 25 over 8, or 50 over 16. I'm just doing this mentally. I'm just plugging it in. Plus 3, which would be 48 over 16. So that's 25 over 16 plus 48 is 68, 73 over 16. What? All right, so it's got to be the integer right above 73 divided by 16. Which is 5. All right. Now I'm going to show you how to do it in Desmos all the way. Oh, wait a minute. That's 5 is what f over 5 has to equal 5, which means f is 25. Wow. That almost got me there. Okay. Anyways, but let's do it now all organically. Negative 4, no, not organically, all from Desmos, I should say. 5x plus 3. So there's my parabola. And now I can quickly see that there is my vertex at that 4.653, whatever. What did I say it was? It was 73 over 16. So you can see that that's what I calculated by hand. It matches this as well. And then we can also say 5y equals f, or equals maybe a or c. Oh, it's not letting me do it with the constant. So we'll just say... how about this? Y equals, let's see if this works, f over 5. Well, let me add a slider. No, it's assigning a value. Okay, that's not helpful. So now we can play around, right? We can say, let's just throw in some values. Let's say 20. Nope, still hitting it. 1, 2, 3. Oh, 23. Wait, 23. Oh, I just realized something. It's not the least possible integer value of, like, it's not that y equals 5. It's that f is the least possible integer value. I almost got this wrong again. Good thing I double checked it. Look, so f is the value on top. 22 doesn't work. 23 does. 24 doesn't. I mean, 24 works too, but the least one is 23. You see, I almost made a mistake just now. So it's a good thing I double checked it. Okay, I hope that makes sense. So 5y, here, let's do it in the proper way. 5y equals 20, 21, 22, 23. So there it is. F is 23. All right, submit. Let's move it on to the next one. And here we go. Which expression is equivalent? Okay, this one I got to go faster because module 2 is tough. 7z plus 3z, that's 10z to the 5th, so it's got to be either B or C. And then negative 9 plus 6 is negative 3z to the 4th. D is the winner. Done. Bakery sold 600 items. 561 were cupcakes. What percentage was cupcakes? So it's just straight up 561 out of 600. And that's 0.935, which is 93.5%. Boom, done. Next. 5, blah, 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 blah. What is the value of 6t? All right. Linear equation. So I got 15t minus 40 plus t. Oops, that looks funny. That looks like a t and a t. Equals 65 minus 2t. Okay, let's combine like terms. 15 minus... Oh, that looks like... Hold on, let me make that look better. 15t plus t is 16t minus 40, and then I'll add 2t, that's 18t, add 40 to the other side equals 105. And then we want 6t, so we'll divide both sides by 3. I'm not going to go to t all the way. So that's 6t equals 105 divided by 3 is 35, I believe. So 35 is the winner. Done. Oh, shoot. Hold on. I just messed something up. Let's just make sure 6t is 35. Yeah, right? And then t is 35 over 6. Yeah, I'm sure it's right. Here, let's just double check it. Here. So again, if we're double checking no, you know what? I got to move on because we have limited time. All right, 2z minus 6, 2z minus, what is z minus 3? 1 second. I just, I lost my Miro tab. I'm going to have to create a new one. Okay. So 2z minus 6, here we go. What is the value of z minus 3? Oh, I know what I can do. Let's save a little time. I can subtract 5 times 2z minus 6, almost like it's a term. So then it's 2 times 2z minus 6 equals 44. Divide by 2, 2z minus 6 equals 22. Divide everything by 2. And then I got z, oh, I said x, but z minus 3 equals 11. And that's what they're asking for. Z minus 3, A is the winner. Done. 2 types of widgets. Factory produce 150 small, 200 large per day. This is the equation where equation represents the daily production capacity in terms of labor hours. What is the best interpretation of 200y in this context? Wait, hold on. $150 small widgets and 200 large widgets per day. Per day. Wait, I think that's supposed to say per hour. Okay, because it's 100 small widgets and 200 large widgets per hour. And that would mean that 200y is going to be... Oh, wait a minute. This doesn't make sense. Factory can produce 150 small widgets and 200 large widgets per day. What's the best interpretation of 200y? Oh, that's the number of hours y is the number of hours per widget. So that's the total number of hours for producing large widgets. It's the total number of labor hours producing large widgets. Yeah, there we go. Okay, 6, triangle size ratio 5, 12, 13. Shortest side, increase it by 5 units. How must the perimeter of the triangle change to maintain this ratio? So shortest side increases by 5 units. Let's see. Triangle sides in the ratio of 5, 12, and 13. How must the perimeter of the triangle change? Oh, got it. Okay. So if the shortest side increases, so right now, the perimeter, if it's 5, 12, 13, it would just be 17 plus 30 is 30. And then if it doubles, right, then it would be 10, 24, 26. So now the perimeter would be 50, 60. So it increases by 30. Yep. Okay, there we go. Boom, done. The equation relates the number of y to negative 20 and y is greater than 0, which correctly, okay, so this is isolating quantities, so we're just isolating s. So I'm going to, let's see, multiply both sides by s. So I have y times s plus 20 times y equals 10. Now let's minus 20y. 10 minus 20y equals ys. And then we're going to divide both sides by y. And we got s equals 10 over y minus 20y over y is 20. Okay, let's see. S equals 10 over y minus 20. It's A. A is the winner. Done. The expression is equivalent to this, blah, blah, blah. What is the value of D? Okay, so what do they do, it looks like? It looks like they multiplied top and bottom by 7 to get to there, right? So 7 times top and bottom, which you're allowed to do, 7 over 7, right? That's 35 over 21x plus 7D. So everything matches up, right? 35s match up, 21x matches up. The 7D, therefore, must match up with 93, which means, not 93, 63. 63 divided by 7 is 9. So that means 9 is the winner. Done. Okay, circle G in the xy plane is equation. Boom, boom, boom. Circle H, the same center. Circle G, radius of circle H is rad 5 times the radius of circle G. Hold on. Okay, so the same center. So the center here is 1 comma negative 6. And then the radius here of the first one is 5. So it's got the same one, same radius. Same center. But the radius here is rad 5 times that. So 5 rad 5. Still 1 comma negative 6. Okay, got it. So they want P. And remember, P is the radius, which is this value, squared. So that becomes 25 times 5, which is 125. 125 for the win. Done. Okay, next. Hold on 1 second. All right, here we go. The library plans to buy the same model of desk lamp for each of its 45 study years. Total budget spent on the desk is $5,000, including 8% sales tax. Which of the following is close to the maximum possible price per desk lamp before sales tax? Okay. So we got 45 times X, including a 8% sales tax. So increase that by 8%, and that's supposed to equal or be less than 5,000. We'll just say equal 5,000. So then we're going to isolate. We're going to divide both sides by 1.08. We got 45x equals 5,000 divided by 1.08. We're going to use Desmos for that. 5,000. And then that value, we have to divide by 45. So then this value, we have to divide by 45. And we get 102. So then it's 102.88. There it is, B. B is the winner. Done. Okay, next. The graphs of the equations in the system of equations intersect at the point xy in the xy plane. What is the possible value of xy? All right, I'm just going to go straight to Desmos. Check this out. 9x equals, notice I just type it in as is. That's the beauty of it. The other one, we have 6x squared equals y plus 86. And they want one possible coordinate. So let's see where they intersect. Okay, here's 1, 2.5, negative 48. So that's 5 halves. And then negative 48.5 is This one. No, but that's wrong. Okay, that one's not there. And then let's see the other one. -1, -80. B is the winner right there. You see it? All right. There we go. Boom, done. 12. How many solutions does this have? All right. I could probably do this by hand. I could do it in Desmos too, but... So I got -15x plus 30 equals 30 minus 15x. They're exactly identical on both sides, so that gives us 0 equals 0, which means infinite solutions. Anything works, okay? The quadratic function j is graphed on the plane where y equals j of x. Its vertex is 4, 3. Okay. Oh, I can show you how to do this one by hand as well. So if the vertex is at 4, 3, and one of its x-intercepts is 1, okay, blop. Well, this is symmetric around the vertex, right? So if the vertex is lined up with 4, one of them is 1, which is 3 away. The other one is going to be 3 away to the right, which is going to be at 7. So that means that C is the winner. Done. Okay. 14. Here we go. The graph y equals k of x minus 10 is shown, which defines k. All right. So this is k translated down by 10. And I'll write out the equation for this. It's -3 slope, y-intercept of 8. -3x plus 8. But this is shifted down already. And then so I'd have to shift it up by 10 to get k. So I'm adding 10, so it should be y equals -3x plus 18, right? 10 plus 8 is 18. There it is. K of x is this. Boom, done. 15. C is a constant for which of the following values of C will the equation have no real solutions? In the given equation, C is a constant for which of the following values of C will the equation have no real solutions? Okay, this is discriminant. And no real solutions means it's a negative discriminant. Discriminant, if that's A, B, and C, it's B squared, which is C here, minus 4AC is less than 0. C squared minus 100 is less than 0. C squared is less than 100. So that means C is either less than positive 10 or greater than negative 10, right? Those will give us values that are less than 100. So 5 is the only viable option, right? It's not 10. It's not negative 10. Not negative 25. That's not greater than negative 10. So it's 5. Given the linear equation, boom, m and n are constants. The x-intercept is at C0, and the y-intercept is at 0D. Slope of the line is -3/4. Okay, wow, a lot of information here. Let's see if we can break this down. So we can start to figure this out by plugging in, okay? So if I plug in 0 for y, I get mx equals 21. So x is 21 over m. And that's my C value. So C is 21 over m. Hold on one second. Hold on one second, guys. Sorry, guys. Just sending a text. Okay, anyways, back to this. C is 21 over m. Now we can figure out what D is. D is the y-intercept. So if I plug in 0 for x, that means ny equals 21, right? And then what's that y-intercept? Divide both sides by n, y equals 21 over n. Okay, so that's D. So D is 21 over n. Okay, then it says the slope of the line is -3/4. Okay, so we got 2 points, right? Let me write this out. We got 21 over m, comma 0. And then we've got 0, comma 21 over n. And so then, oh, wait a minute. Wait a minute, what am I even doing? I don't even need to do this. I just did way too much work. I'm so sorry. Look, I can even leave the points as is. This is crazy. C comma 0, 0 comma D. The slope of the line, if it's got these two intercepts, those are 2 points, just subtract down. 0 minus D is negative D. C minus 0 is C. So negative D over C is equal to negative 3 over 4. That's the slope. But they want positive D over C, so just make it both positive. D over C is 3/4. Okay, wow. Did way too much waste of time there. In the given system of equations, R is a constant. If the system has infinitely many solutions, meaning the two are identical. Okay, so let's put them both into the same format. Top one, I'm going to get it into slope-intercept form. I'm going to subtract 7y, that's negative 4y equals negative 2x plus 14. Divide both sides by negative 4. Y equals 1/2 x minus 7 over 2, right? 14 over negative 4. Set negative 7 over 2. Now let's do the same for this one. We've got r over 3y equals x minus 7. Multiply both sides by the reciprocal, which is 3 over r. Y equals 3 over rx minus 21 over r, because we're multiplying by 3 over r. So 3 over rx minus 21 over r. Okay, and we need everything to be the same, slope and y-intercept. And the only way 3 over r is going to equal 1/2 is if r equals 6. Now, these are going to have to match up. Otherwise, this problem is flawed, but it works, right? You see, you plug in 6, and you divide top and bottom by 3, and you get 7 over 2. So, anyways, r is 6 for infinitely many solutions, meaning the equations are the exact same. Boom, done. An equilateral triangle has side length. Okay, area. We just talked about this in the video. But I'm going to show you 2 ways to do it. So, again, 14, 14, 14. Remember, it's side length squared, which is 14 squared, which is 196, rad 3 over 4. And 196 divided by 4 is 49, I believe. And so it's going to be option C. But if you forget this formula, remember, you can always drop an altitude. And when you do that, you create a 30, 60, 90. And if you drop an altitude for an equilateral, that side is half, is 7. Okay? And then the altitude is 7 rad 3. And then to get the area of the triangle, it's 1/2 base, which is 14, times height. So that's 1/2 of 14 is 7 times 7 rad 3 is 49 rad 3. So that's not too bad either if you need it. Okay, 19. For the linear function g, table shows values x, and it's a linear equation. Function g is defined by this, where c and d are constants. What's the value of c over d? Okay. Let's figure it out. C and d, so that's slope and y-intercept. Okay. Trying to make room here. Let's see if this works. Okay, so we got a couple coordinates. So I'm just going to use 2. I'm going to use -1, -9, and I'm going to use 1, 0. And we're going to subtract down to find the slope. -9 minus 0 is -9. -1 minus 1 is -2. So my slope is 9/2. So it's y equals 9/2 x plus whatever my y-intercept is. Now I'll plug in another coordinate, which is 1, 0. So plug in 0 for y, 1 for x. So that means b is -9 over 2. So then we have our equation. Oops. Bring that back. Y equals 9 over 2x minus 9 over 2, right? I want to make sure this is good. If I plug in -1, I get -18 over 2, which is -9. Plug in 1, I get 0. Plug in 3, I get 27 over 2 minus 9 over 2, which is 18 over 2, which is 9. Okay. So we confirm this works. Oh, there's the full equation so you can see it. And then C and D, that's the slope and the y-intercept, they want the ratio. So C over D. So 9 over 2 over -9 over 2. That's just -1. So that means A is the winner. Done. All right, 20. Data sets consist of 12 positive integers less than 100. The list shown gives 11 of the integers. The mean of these integers is 75. If the mean of data set D is an integer that is greater than 75, what is the value of the largest integer from data set D? Wait. Oh, but they have to be less than 100. Okay. So let's see. What is the value of the largest integer from data set D? Okay, let's try this out. So the mean of these is 75. So that means the total is 11 times 75, right? So it currently adds up to 825. And then we're adding some constant, 825 plus C. And we're dividing this by 12. So we're getting we're getting an average. And this average, it says the mean of data set D is greater than 75. So that means this new number we're adding has to be bigger than 75, at least 75, but it has to be less than 100. And we're supposed to get an integer value. So if C is 75, I get that same integer mean, which obviously isn't right? So you can see it here. There's the 75. So let's now kind of edge it up. 76. Nope, that's not an integer. You can see it up here, right? 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87. There we go. 87, and we get 76. So it's a integer that is, the mean is an integer greater than 75, which is 76, and the value is less than 100. So I think we got ourselves a winner. 87. Boom, done. 2 questions left. Here we go. And exams in 9 hours, you got to sleep. Yeah, no worries. Go do your thing. A zoo charges $1,200 for the first 40 people in groups of 40 or more, and $20 for each additional person. So hold on. We're going to kind of do it like this, because we're eventually going to come up with the equation for the line. So $1,200 for the first 40 people, and then everybody more than 40, so n minus 40, the difference of, beyond 40, is going to be $20 per person. Okay? There's my function, but they don't have that function, right? What do? They distribute and they simplify. So that's 20n minus 800 plus 1,200, and that's 20n, negative 800 plus 1,200 is 400. 20n plus 400, A is the winner. And that's how you do it. Now, you can also not do that and just be like, well, I know that if I have exactly 40 people, it should be 1,200. So you can plug in 40 for all of these. And like this one clearly doesn't give you 1,200. This one actually does. This one will not. So you can cancel out 2 of them just like that. Then for like 41 people, 41 people, it should be 1,220. So which one gives you that? Obviously A will. So I already told you it's the right answer. But what was the other one I said? I think it was C. Yeah, if you plug in 41, it's going to be 50 more, not 20 more. So C would be out. You can check it that way. All right, 13 minutes left. We're in good shape. Let's draw this out. GHI, I'm assuming these 2 triangles are similar or maybe congruent. Let's see. So GHI and JKL, angles H and K are 90. Okay, boom and boom. GH is 8. Hold on. GH is 8. And JK is 24, I guess. JKL, GHI. Okay, we're trying to prove that they're similar. Now, we got a proportionate side, 1 to 3. If we're going to do side angle side similarity, we need these 2 sides to have a 1 to 3 ratio. Or we can show any other 2 angles are congruent in the triangle, and we'll have it. Okay, let's see. So first it says HI is 6, and KL is 18. 1 to 3, that does it. That gives me side angle side similarity. So let's mark that, but let's keep going. HI is 10, KL is 10. HI is 10. No, they shouldn't be equal. They should be proportionate 1 to 3. The measure of G and J are 60 and 30. G and J are 60. Well, hold on. G and J. So this is kind of interesting. G and J are 60 and 30. So G would be 60. J would be 30. But the thing about this is that would make that 60 and that 30. This would actually be angle-angle similarity. But the thing is, in the order they gave it to us, GHI is similar to JKL. It has to be in that order. And if this were the angles, it would be IGH is similar to JLK. You get what I'm saying? So the order would be off. Measures I and L are 60 and 30. And I assume this is going to be the same thing. I and L are, yeah, that'll be the same thing. So it would give angle-angle similarity, just not the way that it's written out. Somebody said, sir, I hope you get the best things in your future life. Thank you so much, man. I really appreciate that. Thank you for the support, guys. Okay, here we go. Let's submit, and let's see how we did, if we got anything wrong. I know I had time left. Now, if you have time left over tomorrow, obviously don't do what I just did and hit submit. Go through and check your answers. Make sure you didn't get a mistake. Look, I did make a mistake. I don't know what I did, but let's take a look. Okay. Got all these wrong, but that I skipped those. All right, let's go to the math. Okay, module 1 is all good. Remember, I almost got one wrong in module 1, number 20. Okay, let's see. So I put 87. Now, wait a minute. Did it say even? The mean of data set D is an integer that is greater than 75. What is the mean of the largest integer? So 87, they didn't like it, huh? Was it 99? Oh, they wanted the largest possible integer. I bet you it's 99. I would have, let's see, yeah, it's 99. So I would have said, the way I would have changed this is, it's a little ambiguous, that language, right? It says the mean of the data is an integer greater than 75. What is the value of the largest possible integer from data set D? Because my 87 fit the criteria, and then 87 would be the largest integer of this set, right? So I felt like that fit the criteria. But they wanted, hey, can you give us the largest possible? Because 99 would give you a mean of 77. Okay, because it would bump it up one more notch. So anyways, that's that. I think that, I guess, whatever. I think that language could be a little bit clearer, in my opinion, but otherwise, that's fair. Okay. All right, guys. I hope you guys enjoyed that practice test. These are the best way to learn, as I've often said many, many times. So I hope you found that valuable. All right, let's get back into the mix here. Yeah, the wording was a little strange. I agree. Assad, thank you. Okay, we're going to get back into the mix. We're just going to burn through a million of these questions. Here we go. I'm going to skip the quiz. All right, number 5. Solving systems of linear equations. Y equals this, for which of k to the system have no solution. That's when the slopes are the same, the y-intercepts are different. So the slope has to be the same, which is 0.25. If you distribute it out, we'll have different ones. So, boom. Which of the following accurately describes all solutions to the system shown? 4y. If I add 3x to the other, it's got to have no solution. Because if you add 3x to the other side, you get 4y equals 3x plus 40. Divide both sides by 4, you get y equals 3/4 x plus 10. That's the slope of 3/4. Divide both sides by 4 there. Y equals 3/4 x minus 30 over 4, right? So we have different y-intercepts, same slope. That's no solution. Okay, consider the system. How many solutions does it have? Let me see if I can. It's infinite. I can tell you why too, because we could graph them. We could do, elimination or substitution. But if you multiply by 4, you get the exact same as the top. Negative 20x plus 12y equals 24. And when they're identical, we have infinite solutions. So C is the winner, done. Okay, here we go. Consider the given system of equations. X, y is the solution to the system was the value of x over y. Okay, so we need to find the solution here. I am going to, wait a minute. I'm going to substitute. Look at this. 2 minus y is 6x. There's 2 minus y. I can plug it right in. 3x plus 4 times 6x equals 5x. That's 3x plus 24x is 27x equals 5x. Wait a minute. Oh. It's going to be x is equal to 0. 22x equals 0. X equals 0. If x equals 0, y equals 2. Right? You plug it in here. 0, 2 minus y is, y would have to be 2. So we want x over y, which is 0 over 2, which is 0. Let's just make sure. 0 and 2. Yep, 0 and 2. Yeah, that's right. All right. We did it. Next. Apollo's economics course requires 2 papers on one long and one short throughout the semester. This is system of linear equation word problem. The number of pages L in each paper is one more. Hold on. Whoops. Where did my thing go? The number of pages L in the long paper is one more than 2 times the number of pages in S in the short paper. And then it says the total number of pages is 40. How many pages? Okay. So we can do a little substitution, right? S plus 1 plus 2S is equal to 40. So minus 1, that's 39, and then that's equal to 3S. Divide by 3, S is equal to 13. So if S is 13, in the long paper, plug it back in here. 13 times 2 is 26, plus 1 is 27. So there it is. All right, next. Vegetable stand sells pea pumpkins for $5. So we got pea pumpkins for $5, and we've got $3 for S number of squashes. And it says on Monday the stand sold 6 more. On Monday the stand sold 6 more squashes. So there's 6 more squashes than pumpkins, 6 plus P. And they made a total of $98. Okay, so that means these two added together is 98. Which system of equations can you... Okay, so we just want to find the equation. We don't care about solving it. So we need 5P plus 3S. They have that backwards there. 5P plus 3S equals 98. S equals P plus 6. I had 6 plus P, but it's the same thing. So C is the winner. Done. You see, I'm always setting up those equations regardless, even before I read it. Right? I'm going to piece it together. The equations are going to come in handy, whether it's that type of problem or whether I need to solve it. So that's my default. Okay, Jerry has a large car which holds 22 gallons of fuel and gets 20 miles per gallon. Kate has a smaller car which holds 16.5 gallons and gets 30 miles per gallon. Okay. If both cars have a full tank of fuel now and drive the same distance, and how many miles will the remaining fuel be in each? Wait. Okay. So he's starting at, wait a minute, 22 gallons. Oh, thank you. We're starting it with 22 gallons and we get 20. Wait, what are they saying? And how many miles will the remaining... Oh, will the remaining be different? Okay, got it. So we're starting with 22 gallons, and every mile driven, right? If I drive 20 miles, that's going to be 1 gallon. So I'm taking the number of miles driving, and I'm dividing it by the miles per gallon. So if I do 40 miles, right, that's 2 gallons, etc. So I'm minusing that. And I'm looking to see when is this equal to Katie's fuel, which is 16.5 gallons, minus x over 30. Okay, now we got an equation. Now we can solve. These fractions are annoying, so I'm going to multiply by the LCM of 20 and 30, which is 60. Or wait, no, let's use the calculator. Here, check this out. So I got 22 minus x over 20. And here, let's do it here. 22 minus x over 20. That's 1. And then the other one is 16.5 minus x over 30. 16.5 minus x over 30. And let's see where they intersect. Right here, 330. So when they've driven 330 miles, they'll both have 5.5 gallons left. So C is the winner. Done. Okay. Now it says a concert venue sold 2 types of tickets for an upcoming concert: reserved tickets and general admissions. Reserved tickets sold 50, and each general admission ticket sold for 34. That many tickets were okay. So watch what I'm going to do. 50 for, oh, and I can see down here it is an equation. So 50 per general admission. 50 per reserved plus 34 for general admission equals a total of 64,000. And then the number of tickets, R plus G, is equal to 1520. That's this equation right there. Look at that. It's A. A. Did I mess it up? 50G. Oh, no. They flipped the variables and I missed it. Sorry, guys. 50R. It's that one. Plus 34G equals this. R plus G. Yeah, it's that one. My bad. My bad. My bad. Rushed. Okay, here we go. Let's move it on to the next one. Okay, here we go. A particular company charges advertisers a one-time cost of $500. Let's write this out. $500. In addition to $4.50 for every 1,000 times an advertisement is shown. Okay, so 4.5 every time a 1,000 times an advertisement is shown. An advertiser wants its ad to appear m,000 times. So I don't need to divide by 1,000. That's what I was thinking. But if m is the thousands of times, 4.5 m, right? But does not want to spend more than 5,000, so less than or equal to 5,000. And then we got our equation. Now we just match it. 500 plus 4.5 m is not greater than, is less than or equal to 5,000. Does not want to spend more than, but it can be equal to 5,000. So that's why hey, how am I making mistakes here? Oh my God, I'm not reading this carefully. I'm sorry, they flipped the thing. It's this one. 500 plus 4.5. Oh, you guys know, I'm getting it right. I'm just clicking the wrong thing because I'm not reading carefully. Okay. Ali Khani says, good luck to everybody. Thank you, Ali. That's nice. Okay, here we go. So spend no more than 300 on school clothes, spend 75 on a jacket, and wants to buy some amount of shirts that are $10 each, so 10 times X, and no more, that's less than or equal to 300, which inequality represents this. So we're basically, I said X instead of S, but we're just going to isolate now. So I got 10x is less than or equal to 225, divide by 10, x is less than or equal to 22.5. And we can't get a, half of a shirt, so we're going to have to round it down to 22. Boom. All right, cool. And now it says this one, water and other materials necessary for biological activities are absorbed by the roots, blah, 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 blah. Water may travel as fast as 150 feet per hour, so I'm writing that down. Which of the following inequalities best describes the number of minutes, m, after being absorbed by the root that it takes for water to reach a height of 250 feet above the ground. So we're going, let's see if we can figure this out here. So 150 feet per hour. So we have rate times time. And I know that time is going to be in hours because feet per hour. I know that. We're going to convert it afterwards. 150 times time. Actually, let's do time over 60. That converts it right there. So if we're plugging in minutes, if I divide the number of minutes by 60, that's hours. So this is all good. For the water to reach a height of 250 above the ground. So I guess we could say equal to, but we'll say greater than or equal to 250 because I think that's what they have. And there we got our equation. Now we just want to isolate, or wait. Oh, no. They just left it like this. They simplified. 150 divided by 60. That's 15 over 6 divided top and bottom by 3. It's 5 over 2t is greater than or equal to 250. And they said m, we said t. Same thing. And that is D for the win. Done. Okay, a 300-acre farm produced 20,000 bushels of corn last year. What is the minimum rate of production in bushels per acre? Okay. What is the minimum rate in bushels per acre? So that the farm's two-year production total will be that. All right. 20,000 bushels. All right, so we need rate times time equals 49,100. So we know the time is 2 years. And then we need a rate of production, which is X, that has to equal this. Okay. Literally just divide by 2. That's 24,550 bushels of corn per... Wait, is that right? No, what am I saying? That's bushels of corn they need to produce per year. And then, so what is the minimum rate of production in bushels per acre? So I need to do this many per 300. So there's my rate. So I need this many bushels divided, and then per acre divided by 300. All right, let's use the calculator. 24550 divided by 300. And we get 81.83. Wait. Uh-oh. That seems weird. Hold on. It doesn't say a fraction. Wait. Oh, it already produced 20,000. So now we need to get 29,100 divided by 300. Sorry. So we just need that additional, that overage. 29,100 divided by 300. There we go, 97. That's a little clue there. Like, I felt pretty confident we shouldn't be getting a fraction. It didn't say to round or anything, so that's why I went back and reread it, and that's how you catch mistakes sometimes. Whoops. Okay, let's move on. Number 8. Let's go. Which of the following ordered pairs XY satisfies the system of inequalities? All right. Now, I showed this in the Desmos hack, so you can graph this and see. But this one, since there's only 2 equations and each one is 1 point, you can just plug and chug. So -1, 0. So if I plug in 0, plug in -1, 0 is less than 1. That works. Plug in 0, plug in -1. 0 is not less than -3. So A is out. Plug in 7, plug in 1. That's out because 7 is not less than 7. Plug in 11, plug in 2. 11 is less than 10. That's wrong. Plug in -4. -4 is less than 13. Yes. -4 is less than 17. So D is the winner. Okay. Next. In which of the following does the shaded region represent the solution set in the XY plane? All right. So we've got y is less than or equal to this. Y is less than or equal to this. Oh, yeah, let me write it like this so we can see it as we move down, hopefully. 1/3 x minus 3, and y is less than or equal to -2x minus 2. Oh, yeah. Hey, Louisa, can you take him out in the back? Because he might have to go. Sorry. He hasn't. Yeah. Thank you. All right, so we got these two inequalities. Now let's scroll down, right? Less than or equal to and less than or equal to. One is a positive slope of 1/3 and a y-intercept of -3. That looks right. One is a slope of -2 with a y-intercept of -2. Actually, this looks right. The problem is the shading's wrong. It's less than and less than, so it should be down here, actually. Oh, actually, it's C, because all the graphs are the same. It's just where it's shaded. So the reason why this is right is because we're going below this one and below that one, so the intersection is that region. So anyways, C is the winner. Here we go. Done. Okay, if the shaded region of the graph versus the solution set, which of the following could be the system? All right, let's see. It's going to be greater than and greater than because it's above and above. So I'll do it. And they're both solid, so it's going to be greater than or equal to. So y is greater than or equal to. This one has a y-intercept of -1 and a slope of, let's see, up 2 over 3. 2/3 x. This one is y is greater than or equal to, and this one is a slope of, or y-intercept of -2 and a slope of up 5 over 2. All right, so those are our equations. Now let's go down. Wait, did I get that wrong? Oh, that should be up 3 over 2. My bad. Up 3 over 2. Okay. So y is greater than or equal to 3 over 2x minus 1. And y is greater than or equal to, it's this one. Yeah, it shouldn't be a less than. Shouldn't be a less than. Yeah. Oh, all the equations are the same. All right. Didn't even know that, but. Which of the following does the shaded region represent this solution set? So I'm going to put it in the slope-intercept form because otherwise you don't know which way to shade above or below. So it's 3y is greater than or equal to 4x. I'm just flipping it around, 4x, and then I'm minusing 3 from both sides. Divided by 3. Y is greater than or equal to 4/3 x minus 1. So we need to be shading above. So that's -1 and then a slope of up 4 over 3 above. I mean, it's got to be A. Let's just see the other ones. Wrong y-intercept. Right y-intercept, but shaded the wrong way. Wrong y-intercept. Okay. All right, let's keep it going. We're going to skip the quiz, and we're going to go to, now we're on to ratios, rates, and proportions. Man, hello. Literally yesterday I watched your Math Bible video, and today after 9 hours I'll be taking the SAT. Your video was useful, by the way. Amazing. So thank you for saying that, Hassan. By the way, if you haven't checked out the Desmos video I released last night, I highly recommend it. Actually, let me post it in the link right now, or in the chat. I think for a lot of you guys who are doing this last minute prep, it's going to really come in handy. Also, if you are looking for more practice tests, make sure to check out the SAT crash course. You can see at the top the link. You can use the code SCALAR and get 20% off. So I highly recommend that. Okay, hold on one second. Let me get this video for you. So it's Desmos Hacks. Yeah, and I mean, it's people are really like it. It's so good. I like, not to pat myself on the back, but I really thought about it carefully. I think it's got some amazing tips in there in terms of how to use the calculator and just blast your score up 100 or even 150 points. So there's the video. I just posted it in the chat, so make sure to check that out. Okay. Let's do ratios, rates, and proportions. Historically, one of the most popular categories for on the SAT in terms of what the College Board likes to use. All right, to properly view a Snellen eye chart, whatever that is, if the tallest letter is 88, the person should stand 6 meters. I'm already setting up a proportion because I know this is ratios, rates, and proportion. Just remember to label millimeters and meters. The distance is proportional to the height of the tallest letter. How many meters from the chart should one person stand if the tallest letter is 45 millimeters? See, I almost put it in the wrong spot. That's why I label. All right, and then this is x. So now we got a proportion. Now we can solve. Round to the nearest hundredth of a meter. So we got 88x equals 6 times 45. That's 240 plus 30 is 270. So we got to do 270 divided by 88. Let's do that now. 270 divided by 88, which is 3.06, 3.07 to the nearest hundredth, right? 3.07. Boom, done. Okay, next. According to Einstein's energy mass equivalence equation, the energy of an object is proportional to its mass. All right. So energy is proportionate to mass. And so then let's see. We've got a mass of 8.1 and energy 7.29 times 10 to the 14th. Yikes, with the scientific notation. How much energy does 1.7 grams, that's mass, 1.7 have? There's my unknown. Okay, we're going to cross multiply. 8.1x equals, I'm going to put this in Desmos, 1.7. 1.7 times 7.29 times 10 to the 14th. I'm going to have to double check, make sure I wrote those down right. 7.29 times 10 to the 14th times 1.7. Yep, and then we have to divide by 8.1. So we go parentheses, divide by 8.1, and we get 1.53 times 10 to the 14th, which is B. Boom, done. All right, nice. Next, when David arrived in the country of Georgia, he exchanged 165 US for 385 Georgian. There's a famous UFC fighter right now, Georgian fighter, Ilia Topuria, current champ. So pretty cool. That's been talked about a lot. Georgian and from Spain. Same with Merab. No, he's not a champ yet. When he is ready to return to the U.S., he has 147 laris left. How many U.S. dollars is this worth? So again, that's the Georgian currency. There's my proportion. Let's solve. 385x equals those two multiplied, 165 times 147. These numbers are not exactly what I would expect on the real SAT. You notice the College Board doesn't use these numbers typically. I mean, it could happen, but okay. So then that equals, what is it? 24,255. And then we're going to divide that by 385. And we get 63 on the money. 63. Boom, done. Okay. Next, let's see. A certain movie theater ratio of length to width of the movie screen is 16:9. And if the length of the screen is 90 feet, oh wait, we should say 16:9x when they say it's in a ratio. If we know the length of the screen is 90, wait, hold on, length to width. So this is 90. So we know that 16x equals 90. Then how many feet is this width? So we're going to solve for x, divide by 16. That's 45 over 8, and then plug it in here. So multiply that by 9. So 9 times 45 over 8, which is, here, let's do it in Desmos. 9 times 45 over 8, which is 50.625, which I guess is 51. We'll round it up. Boom. There you go. Okay, next. I think he might want to go out again, or did he already go? Oh, okay. Then I don't know. He was looking at the door. Okay. Sorry, guys. We're going to keep it rolling here. Wait, what is this? Unit 2 conversions. Oh, yeah, here we go. Medium. And let's go. What's up, Abdullah? Great to see you on here. All right. Nadine has 4 gallons of gas in her car. If the fuel efficiency of her car is 23 miles per gallon, 23 miles per gallon, how many miles can Nadine drive before running out of gas? So she's got 4, and we're trying to figure that out. Cross multiply, 1x, and these are just labels. They're not part of the equation. 4 times 23 is 92. So we got 92 is equal to x. 92 for the win. Boom, done. All right, next, the shipping route from Los Angeles to Honolulu is this. Approximately how long is the route in miles? All right, so 1 nautical mile. So watch how I'm going to label it. 1 nautical mile to regular miles. And then we've got 1946 nautical miles to regular miles. There we go. Cross multiply. So it's 1.15 times 1946. And we got 2237.9. 2237.9. So that rounded up is this. Boom, done. Okay. Customer acquisition cost, or CAC, is equal to the total cost of marketing and sales divided by the number of new customers. If a customer spent $570,000 on a marketing campaign and got 60,000 new customers, what is the CAC in dollars per? So it's literally this. I set it up. When they say dollars per customer, that word per means multiply. So it's literally dollars per that divided by 60. Okay, so 570 divided by 60, which is 9.5. Let's see. 9.5 is C. Boom, done. Okay, next. In Australia, the wind gusts of 20. Okay, what was the wind speed in miles per hour? Okay, so we need to convert. Wait. 220 knots. So we got 1 knot equals miles per hour. So 1 knot is equivalent to 1.15. And then we got 220 knots is equivalent to what in miles per hour? So again, cross multiply 1.15 times 220. And we get 253. So 253 for the win. Done. Okay. All right, let's move on to the next one. All right, percentages, medium. Here we go. A study suggests that 75% of household solid waste can be recycled. However, 30% of his orchid solid... However, the average person only recycles 30%. If the average person produces 4.5 pounds of solid per day, approximately how many more pounds of solid waste could be recycled compared to the amount they... Okay, so... produces 4.5 of solid. Okay, so the average person does 35%. Okay, so right now the average person does 30% of this, but they could do 75%. So they said, how much more could they do? So let's calculate that in decimals. So 30%. 30% of 4.5 is 1.35. And then 75% of 4.5 is this. So we take the difference of these two. 3.375 minus 1.35 is 2.025. So we got that rounded up. Boom, done. Okay. Oh boy, I have been streaming for a long time. My voice is getting a little tired. If you guys could click that like button, I'd really appreciate it. This is a bit taxing on my voice. I want to do as long of a stream as possible for you guys today, obviously because we got test day tomorrow. So I'm going to keep going as long as I can, but I'm just letting you know I'm getting a little winded. The support and the love is much appreciated. Been trying to work really hard for you guys to do this. So yeah, any support would be amazing. Thank you guys so much. All right. Here we go. During last year's basketball season, Jackson attempted 150 free throws, of which he made 120. So he made 120 out of 150. So far this season, he's attempted 24 and made 16. All right, we know what a player's free throw percentage. Assuming calculations began with the start of last year, which of the following best approximates Jackson's overall free throw percentage to date? So it's 120 plus 16, which is 136. That's how many he's made out of a total of 150 plus 24, which is 174. Okay, this is a straight Desmos thing. So 136 over 174. And that's, the decimal equivalent. So times 100 is 78.1%. Boom, done. That's approximate. Okay. Next, we've got for a certain toll bridge, drivers get 11% bonus if they buy credit on a prepaid toll pass instead of paying cash. Okay. If a driver pays $9 for prepaid toll pass, what is the total credit? All right. Wait. Oh, got it. What is the total credit? It's literally 11% of 9. Now we can even do that by hand. So that's 99. Move the decimal over twice because it's 2 decimals, so it's 99 cents. Yeah. Hey, what? What is the total credit? Oh, total credit because you're including the $9. Sorry. I thought it meant the bonus credit. So it's $9 plus the 11%, so it's $9.99. Sorry. I didn't read it carefully enough. Okay, this one. On Monday, a fruit vendor bought 80 pieces of fruit to sell at a market, 35% of which were apples and the rest were oranges. Okay, so 35% were apples. I can do that mentally, I think. 24 plus 4 is 28. On Tuesday, the vendor bought the same number of oranges. Okay, so this is apples. Oranges would be 52, right? Adds up to 80. So she bought the same number of oranges, but she only bought 73 pieces of fruit, meaning 21 apples. So the apples are 21 out of 73. Okay, let me see. And that's 28.7%, which is A for the win. Done. Okay, moving on. Here we go. All right, center spread and shape of distributions. The dot plot predicts annual snowfall in centimeters. Which of the following statement offers the best explanation of the mean and median of distribution? Okay. So median, we're going to add all these values up and divide by 10. So that is 60, 90, 100, 100. So that's 200, 350. Plus 130, 130, that's 260. Plus 320. Plus 170 plus 190. Yikes. Okay, let's add this up. I'll just do it by hand. 0, 11, 12, 13, 20, 29. Carry the 2, 5, 7, 10, 11, 12. So we got 1290. Divided by 10 is 129. So the mean is 129. Now the median is the middle value. 1, 2, 3, 4, 5, and 6. Since we got 2 middle values, but they're both equal, it's still the median. So the median is 130. So the median is bigger than the mean. The median is approximately equal. I mean, they are pretty equal. Wait. The data is symmetric, though. Wait a minute. I might have made a miscalculation because the mean and the median should actually be equal now that I think about it. Hold on a second. What did I do wrong? 70? Oh, I wrote 60. That's 70. Yeah, they are equal. I just realized that. That's supposed to be 70. So then if you change it to 70, it would be 1300 and would be 130. So they're equal. And that's true. When the data is symmetric, the mean and median are equal. Actually, the mode is supposed to be equal too. In that case, it wouldn't have been because there's multiple modes, but... All right, here we go. Histogram shows the results, blah, blah. Which statement best compares standard deviation? So standard deviation is the spread. B is more spread out than A, so B is a greater standard deviation. A is greater. Nope. Standard deviation of B is greater. Yep. That's pretty much it. Okay, next. Here we go. The dot plot depicts the number of home runs hit by members of San Francisco Giants during 2014 baseball season. The player who hit the most home runs was removed from the data set. How would the mean of the data set be affected? Okay. So it says if the player who hit the most home runs was removed, which is this one, 22, the mean is going to go down, right? If you're taking away the biggest value, which is bigger than the mean, it's going to decrease the mean. Even though you're decreasing the amount you're dividing by, but still. Okay, next. A candidate in a local election analyzed the voter data for 7 of the towns where she was on the ballot. If the median number of votes that she received from the 7 towns was 421, then which statement must be true? Okay, my voice is really struggling, guys. This might be the last couple questions I'm going to do. I think I need to let it rest. A candidate in local election. Okay. All right, so the median is 421. No, that's not necessarily true. That would be true if it was the mean. The total number in the votes candidate reached in each of the 7 towns was 60. Nah, that doesn't make sense. Median just means it's the middle. It means there's values below it and above it. That's it. The candidate received at least 421 votes. Yes, that is true because the other values are at least equal to that, but, greater. So I would say C is actually correct. D, the candidates received exactly 421 in 2 of the 7 towns. I mean, that might be, but that's not definitively true. Okay. All right, guys, we're going to pause here. I did a bunch of topics, and we did that practice test, which I hope was cool. If you guys didn't see the practice test, I'm going to stop the live stream, and then you guys can rewind and check it out. Let me see if we got any other things. Any tips for me in the English section? No, this is mostly math. Hey, Rockade, O'Malley versus Vera. You're a UFC fan as well. Yeah, this is going to be a big card. Okay, guys, that's it for today. I'm going to sign off. I hope you guys appreciated this long stream that I did. My voice is going to be feeling terrible tomorrow, but it is what it is. Happy to do it. Happy to help you guys out. If you guys are watching this video, make sure to click that like button. Really helps with the algorithm. It really helps to push through this message that I'm trying to send, help people with math and education. Just bring people positivity as much as I can. By the way, if you haven't checked out the SAT Crash Course, make sure to check it out. Use code SCALER for 20% off. It's the best resource ever in terms of digital SAT prep, in my humble opinion. I've also partnered with them. Obviously, I'm a little biased, but I partnered with them because I love the product and I love the feel. Assad, you're very welcome. Rockade, let's see. Who you got in the fight tomorrow? I got O'Malley, but I think it's going to be a banger. It's going to be a tough fight. Tough fight for both guys. And that's it, ladies and gentlemen. I wish you all the best of luck. Make sure to check out the video I posted in the link, Desmo's Super Hacks. Again, here, I'll show it to you. It's this video. I made it late last night, posted it early this morning, depending on where you're at. So this is the video. I highly recommend it because it is just, you can immediately, stuff that you can learn and apply instantly to instantly boost your score. I've also got the Formula Bibles video that is on the main page. Hey, look, somebody said the channel's criminally underrated. Wow. Wow, that's so nice. Thank you, guys. So anyways, check all this stuff out. do your absolute best. Leave a question in the comment section. If you do have a question related to the SAT tomorrow, I'll do my best to answer it before then. And that's it, guys. You guys are my army of test takers, and I want to see you guys go out there, do your best, come back, and hopefully what we did today is a massive help. So that's it. I'm going to sign off, guys. I was planning to go even longer, to be honest, but I just don't have the endurance. But hopefully that was plenty. All right. Thank you guys so much for joining, and I will see you in the